today in the lecture series of Big Data Analytics, we are covering a very important topic, that is your Hadoop. So Hadoop is a framework which is given by the Apache. As we have already discussed in the previous lectures also, that the data, we are having a large amount of data everywhere. And what is the problem is that we are gathered with huge amount of data and we're not able to manage that data. We're covering the data from the social media platforms, we're getting the data from number of websites, we're getting the data from number of banking systems, from the hospitals. Everywhere we're getting the data. For example, if you are purchasing any shoes or any clothes from the shopping sites, and you are traversing number of different kinds of shoes, pairs, and whatever information you are trying to grasp from that, all the information is getting stored by the specific site. For example, the Amazon. You're traversing the Amazon site, you're moving on to different kinds of products of the Amazon. Each and every point you are covering, you're moving on. That every point is getting collected by the Amazon itself. Your name, your age, and many more features, whatever you are moving on. So the issue is creating is that, yes, of course, all the information has been captured by the Amazon, but how we are able to manage that data? Talking about the number of platforms, for example, the WhatsApp is there, your Facebook is there, your Instagram is there, your Twitter is there. Every 60 seconds, we are generating a huge amount of data. In every 60 seconds, number of likes are there, number of views are there, number of people are uploading lots of videos, photographs, and definitely the charts are there, and number of things are present. But the issue is that this huge amount of data we are not able to manage. And that is why it is raising more opportunities for the analytics purpose, for the data analyst person, for the data science person, and how we are able to deal with that. So for that part, the Hadoop come in the picture. So talking about the Apache Hadoop, Hadoop is a framework that allows us to store and process large data sets in parallel and distributed fashion. On the internet, of course, the data we are throwing, we are moving on, data is only a unstructured data. It is not having any structured format. Structured means it is not in the form of the tabular representation by which the system can understand. System doesn't understand whatever we are throwing, whatever we are moving on to the system. So for that part, for that unstructured data, we have to convert the data into structured data. For the proper formation of that, for handling of that data is very much required. So that is why the Hadoop will come, and the Hadoop provide the information. The Hadoop may process that data properly in the parallel and a distributed fashion. So the two categories of the Hadoop, which was basically designed, the base of the Hadoop design was having the two parts, that is the HDFS and the MapReduce. So here I have given a small example for that we are having the two categories. Here is the distributed file system, and here it is mentioned allows parallel and distributed processing. It is having a small story about that. What a small story is that, for example, I want to open a small restaurant. In that, I want to, for example, I'm selling a pasta. So for selling that pasta, I know I am the person, and I can easily, if one customer come to me, I can simply prepare that white sauce pasta and I can give that pasta to that person. No issues. So in 1 hour, I can deliver 2 pastas. In 2 hours, I can deliver 4 pasta. But the issue raised is that if, for example, my pasta will get more and more famous in the city, the number of people are coming to my restaurant and they are asking to have more number of pastas. So, but I know my efficiency is that I can only prepare 2 pastas in 1 hour. But the issue raising is that the customers are getting more. So what I'll do is that I will try to call more persons, more employees, which can start cooking with me. So I will call some certain peoples and they will start cooking with me. That is okay. We'll call 2 chefs and they start cooking with that. Now it's fine. I can deliver 4 pastas in 1 hour or 8 pastas in 1 hour if I'll have more and more chefs. But the issue raising is that if the chefs are number of four chefs are present in that, but we are having the shelf, the content, the ingredients present in that shelf is only single. I want red sauce by me also. The red sauce is required by some other shelf also, or the white sauce is required by some other person also. At the same time, same ingredient is required by number of chefs. So that is also an issue. So what I need is that I have to need the storage of different ingredients by the different shelves, by which means is that each single chef should have its own storage space from where he can collect or she can collect the ingredients and start cooking that. So it will have the delay in that, isn't it? So that storage system should be accurate. So here it is mentioned, a simple example for that. There is a chef, and what he has done is that he has divided his work to 2 more small chefs, which is working under him. For example, if he's creating the red sauce pasta, he has given that you start creating the red sauce, you start boiling that pasta. So the two works are parallelly executing. You're getting my point? If I am only the one for cooking that pasta, it is not efficient. And of course, it's a time consuming process. I'm boiling the pasta, then I'm preparing the ingredients, I'm preparing the red sauce, and then I'll start the processing my pasta dish. But if I want to be a time efficient, I want to give more and more number of pastas at a small time. So what I'll do is that I will try to divide my work. I will divide my work to one person I had told to prepare the sauce, to the one people, the one chef I told to have the boiling of that pasta. So of course, in a in a limited time, I can provide a number of pastas also. Simple example I'm also giving my more is that, for example, there's a book of a big data. Fine. And I told you that beta, okay, I'm giving you this book. Now start searching in the whole book. How many times the big data word is coming? You start searching about the big data word. No issue. You start counting. You will turn one by one page. You will start identifying the word big data, big data, big data, big data. In every page you will find. It may take 1 week, it may take 1 month, or it may take 1 year also. Maybe the book is very, very large and you are manually doing that process, you will get tired of that, and it is taking a time consuming process. But what I want is that I want this work to be done by the 1 day or by 1 week, you can say. So what I'll do is that I will provide that book to number of students present in my class. For example, I'm having a 60 class of the students. I'm collecting certain students from that. For example, 30 students I'm collecting from the class, and I divided my book to each and every student. Now what I did is that 10 pages I had divided to each and every student. 10 students to the first student, next 10 pages to the second student, next 10 pages to the third student. Similarly, I had divided all these pages to different kinds of the students. Now I told the same task to do by each and every person. That means to identify how many times the big data word coming in those pages. For example, the first student identified that on the first page, the number of big data is having 7 big data. Okay. In the second, the person have identified from 11 to 20, the page number, and he identified that around 3 or 4 times the big data word had come. Similarly, all rest of the students will start doing those work, and they will submit me the number of counts of the big data. Now, what I'll do is that I will merge all these counts and calculate easily that how many times the big data word is coming in this complete book. What I done is that I simply divided the work to different people at a executable manner, and of course it is in parallelly. अगर मैं इसी काम को अकेले बैठ के एक ही बच्चे को कहती करने के लिए, of course not, it's a very, very hectic work. So the simplicity saying is that we can simply distribute that work. We can simply have the distribution of that, and then we can have the execution of that. So HDFS is the distribution, MapReduce is the execution of that Hadoop distributed file system. So now coming on to the Hadoop architecture, for example, the Hadoop architecture is categorized by the two parts, that is the master and the slave architecture. You know very well about the master and the slave architecture. Master is the main person who is holding the complete information, and slaves are the people who are working under them, isn't it? So, for example, we are taking a project manager who is the master. He knows about the project, and what he did is that he had given all the information regarding the projects to different people who are working under him. For example, he had given us a part to work on the project to the John, who is working on the project A. Okay. And then similarly, he had divided the project. He had given certain part of project B to the James. Now, similarly, a small part he has given to the Bob, and similarly, he had given a small part to the Alice. So the project is divided into four categories: A, B, C, and D. That means it's mentioned here a metadata. A metadata holding the name of the people to whom we have assigned the work and what work we have assigned. We have assigned the project A to John. We have assigned the project B to James. We have assigned the project C to Bob, and similarly, we have assigned the project D to Alice. Okay, now there is no issue and everything is executing parallelly. But what will happen if some of the people who are working on these projects, they are not able to work on that? For example, the Bob is defined here. With some reason, he is not well enough. He had suffering from fever or certain issues that he is not able to come to the office, and he had not been able to work on the project C. So the issue will be created. Rest of the projects are moving properly. There is no issue. but the project C is getting delayed, and definitely by which the whole project will getting delayed because they are the sub parts of a single project. We are not able to work on that, isn't it? So for that part, what the project manager will do is that he will try to grasp, or he will grasp the complete information about the people who are working under him, and what kind of projects he or she can do. For example, he has taken the information from the John that on what part of the project you can come comfortably. You can work on the project comfortably enough. For example, project A and C can be done by the John itself. He is working on A, but yes, he can work on the project C also. No issue. Similarly, by the James is working on the project B, but yes, he can work with the project D also. It is also having no issue. Similarly, the Alice, she is working on the project D, but yes, she can work on the project A also. No issues. Similarly, by the Bob can work on project, is working on project C, and he can work with the project B also. So the solution is that if somewhat the Bob is not able to do the work, the project manager can ask to the person who can do work on project C also, that yes, I will give you the extra perks, or I will give you certain promotions, or whatever extra amount he can give to that person, that please start doing work on the C part also. You're working on A, it's very good. You're working your project on time. Everything is getting very smoothly. So now, due to that certain issue, the Bob will not come for the next week or for the next month, of course. You have to start working on the project C also parallelly. So this will not create any issue, isn't it? So that is what the same thing can be done by the Hadoop also. So here it is showing the complete master-slave architecture. So Hadoop works on the master-slave architecture. Here the project manager is the master, and the rest of the people, that is the John, the Alice, the Bob, and the James, they all are the slave nodes. And they're holding all the information regarding their projects also. That is the project A and C, project D and A, project B and D, project C and B. Okay, fine. So we remember that whenever we are talking about the Hadoop, we are talking about the master-slave architecture. So remember with this example only. Okay. Now this representation can be converted into a simple master-slave formation. Here is a master, you can say a CPU is there, a single standalone application is there, which is dealing with the number of the slave units to whom they have given the different informations to have to work on that project. Okay, so we are having the master-slave architecture. So remember that the Hadoop always work on the master-slave architecture. It is having two formations, that is the HDFS, that is Hadoop Distributed File System, and the MapReduce. Two partitioning is been there in the Hadoop system. Okay. So coming on to the Hadoop components, we have discussed, I told you about that also. That is, it is having the HDFS, and it is having further the HDFS is categorized into three categories. That is the name node, the data node, and the secondary name node. Fine. So we'll see that as the name declares name node is basically the master node, which is hold all the complete information about that project or all about the work we are doing. The name node will simply assign the informations to be done by the data nodes. It is the slave. So this is simply a master-slave architecture. The master is the name node and rest are the data nodes, that is your slave nodes. A secondary name node, as mentioned, as the name declares secondary part, if somewhat issue is there, this of course the secondary node is present to deal with that. Name node is working, it is having certain issue, or it is want to have the hold on that part. So at that time, secondary name node will have the information, complete information from the name node. So it's mentioned here clearly. What the name nodes do is that it maintains and manages the data nodes. It records the metadata, that is information about data blocks, that is location of blocks stored, the size of the files, permissions, hierarchy, etc. So remember that whatever the size of the file is there, whatever the permission, of course, it is the whole soul manager. He's a project manager. He should have the complete information about that, whatever working is happening in that. Fine. This is showing the heartbeat also. If somewhat this heartbeat is not received by the name node, that means this data node is not working. So that is issue. So he will assign that work of data node to some other data node, isn't it? So this heartbeat information should be traverse timely. So it's mentioned here, it receives heartbeat and block report for all the data nodes. Whatever the blocks it is having for the storage block is the storage block where the information we are storing, isn't it? So that block information will also be given to the name node itself. Talking about the data nodes, as I had mentioned here, it is a slave. It stores the actual data. It serves the read and write request from the clients. Fine. Now the last one is the secondary name node. We'll extend that also. Secondary name node is basically as of work with, I told you that the name node is not properly working or it is having certain large amount of information is capturing. So secondary name node will help to deal with all these informations. The name node is having the editable log files. It is also having the FS image files. Now what happens is that whatever information is coming, it will move on to this edit log file will traverse the information to the edit log new. कोई भी अगर आपके पास इंफॉर्मेशन आती है, लॉग फाइल्स आती है, वो वहां से इंफॉर्मेशन नई फाइल को देगी. यहाँ पर क्या होगा, यहाँ पर आपकी चेक पॉइंटिंग होगी. चेक पॉइंटिंग मीन्स द इंफॉर्मेशन ऑफ द लॉग फाइल्स विल गेटिंग कलेक्टिव और उसके बाद वो इंफॉर्मेशन वापस जाके चेक होकर वापस जाएगी. दैट मीन्स व्हाट वी आर डूइंग इज दैट वी आर कंबाइनिंग दिस एफएस इमेज पार्ट, दिस एडिट लॉग फाइल, इन दोनों फाइल्स को कंबाइन करके आपका यहाँ पर आएगा. यहाँ पर आपकी चेक पॉइंटिंग होगी. चेक पॉइंटिंग होने के बाद आपका ये इन्फॉर्मेशन कहाँ जाएगा, आपका सेकेंडरी नेम नोड के पास कि ठीक है हमारा काम हो गया है, अब आप आ जाइए. सेकेंडरी नेम नोड के जाने के बाद एडिट लॉग जो है वो फाइल आपकी एफएस इमेज के साथ कंबाइन होके आपकी यहीं का यहीं आपकी एफएस इमेज वापस आपके यहाँ पर आ जाएगी. तो इट्स मेंशन हियर, check pointing is a process of combining edit logs with the FS image. So we are combining this edit log file and FS image file. We are combining these two files. We are giving this FS image file back to here itself. Okay. And this edit log files is getting, आपके पास फाइल्स आती रहेंगी, वो नहीं कि वो अपने पास स्टोर करके रखता रहेगा, वो फटाफट आगे आगे ट्राइवर्स करता रहेगा. एडिट लॉग फाइल आई, फटाफट उसने आगे दिया और आगे उसने ट्रांसमिट कर दिया. ठीक है. एडिट लॉग फाइल आपकी यहाँ पर गई, एफएस इमेज के साथ कंबाइन करा, ये दोनों का कॉम्बिनेशन होकर आपकी फाइनल इमेज फाइल आ गई एंड इट विल फर्दर मूव ऑन टू द एफएस इमेज and then further it will having stored in the information for the further processing. So it's clearly mentioned here, check pointing is a process of combining edit logs with FS image, and the secondary name node takes over the responsibility of check pointing, therefore making name node more available. Name node को हमें रोकना नहीं है because he is the whole manager. अगर वो ही रुक जाएगा इन सब एनालिसिस को करने के लिए तो हमारा प्रोजेक्ट का काम तो रुक ही जाएगा. इसीलिए हमने सेकेंडरी नेम नोड को रखा है. तो बाकी के जो रेस्ट ऑफ द पार्ट्स है, इन्फॉर्मेशन आई, फटाफट इन्फॉर्मेशन को आगे फर्दर करा गया, उसको कंबाइन करके फर्दर आगे वर्किंग के लिए प्रोसेस के लिए आगे छोड़ दिया गया. ठीक है. अलाउज फास्टर फेल ओवर एज इट प्रिवेंट्स एडिट लॉग्स फ्रॉम गेटिंग टू ह्यूज. एडिट लॉग फाइल आपके पास आ रही थी, अगर हम यहीं पर ही प्रोसेसिंग करते रहते तो फाइल्स आपकी बढ़ती चली जाती, इंटरनेट इशू आपका रेज होता जाता, आपकी प्रोसेसिंग की स्पीड आपकी स्लो हो जाती. तो फटाफट क्या हुआ, वो इन्फॉर्मेशन को आगे भेज दिया गया. दैट इज व्हाई इट्स मेंशन्ड हियर, अलाउज faster failover as it prevents edit logs from getting too huge. Fine. Check pointing happens periodically. आपके check pointing का क्या काम है, वो हर एक घंटे के बाद आपके जो है वो आपका एक फ्रेशन अप करता रहेगा, बार बार मूव करता रहेगा. जो भी कॉम्बिनेशन आया डेटा का फटाफट जैसे यहाँ पर आया फिर उसमें फर्दर अर्ली वी आर हैविंग द रिफ्रेशमेंट ऑफ दैट, और वी कैन चेंज द टाइमिंग्स आल्सो एज पर आवर रिक्वायरमेंट. Now how the data is actually stored in data nodes, that is the data blocks. So it's mentioned here, HDFS data blocks, it is each file is stored on the each block. हर एक ब्लॉक के पास आपकी इंफॉर्मेशन कुछ ना कुछ स्टोर रहेगी और आपका जो डिफॉल्ट साइज है वो ईच ब्लॉक का दैट इज योर 128 MB in Apache Hadoop 2. That is which is your 64 MB in Apache Hadoop 1.x. तो Hadoop 2.x के हम बात कर रहे हैं, उसमें आपका बाय डिफॉल्ट स्टोरेज इज 128 MB. ठीक है. तो इट्स मेंशन है, फॉर एग्जांपल जो मेरी फाइल का साइज है दैट इज 380 MB. 380 MB मेरी फाइल का साइज है. अब मुझे पता है मेरे Hadoop के पास बाय डिफॉल्ट साइज इज 128. तो व्हाट विल डू इज दैट Hadoop will divide this partitioning data into three partitioning, 128 plus 128 plus 124, which is equal to your 380. This is how the information has been stored in different blocks, block 1, block 2 and your block 3. Fine. So it's mentioned, it's drawn here that in a simple diagrammatic way, the name node is there, the data nodes are present here, it is having the blocks, and these blocks information has been stored here itself, that is 128, 128 and 124 MB. Fine. Now, what is the fault tolerance? How Hadoop cope up with the data node failure? अगर डेटा नोड का कोई भी फेलियर हो जाता है, मान लीजिए इनमें से अगर कोई भी डेटा नोड आपकी काम नहीं करती, तब क्या? तब तो मेरा डेटा सारा चला जाएगा, इट विल क्रिएट एन इशू। तो उसको मुझे ठीक करना है, उसको मुझे ये होने नहीं देना है। ऑफ कोर्स वी डीलिंग विद द बिग डेटा, वी डीलिंग विद द लाइव स्ट्रीमिंग ऑफ द डेटा, इजंट इट? ऐसा नहीं होना चाहिए। तो उसके लिए हडूप ने क्या करा है? हडूप इज हैविंग अ सिनेरियो दैट इज वन ऑफ डेटा नोड्स क्रैश कंटेनिंग डेटा ब्लॉक्स। मान लीजिए इसमें से कोई भी क्रैश हो जाता है, तो हम क्या करेंगे? उस डेटा नोड की इंफॉर्मेशन को हम किसी और नोड में भी स्टोर करेंगे। दैट मीन्स द replication factor. Hadoop is having a very good quality of that. He is creating, or the Hadoop is creating a replication factor. That means आपका एक ही ब्लॉक के replicas create होंगे, and by default 3 replicas are present in the each Hadoop. जैसे कि हम देख सकते हैं बेटा, नेम नोड है, डेटा नोड है। डेटा नोड मैंने आपको बताया है कि आपका अगर मान लीजिए कोई भी एक डेटा नोड फेल हो जाती है, वो इंफॉर्मेशन आपकी इसके पास भी है, वो इंफॉर्मेशन आपकी इसके पास भी है। अगर मान लीजिए यहाँ पर ये नोड फेल हो गई है, तो वी कैन कलेक्ट दैट इंफॉर्मेशन फ्रॉम हेयर इटसेल्फ आल्सो और हेयर इटसेल्फ आल्सो। अगर कोई भी काम कहीं पर भी अगर कोई ब्लॉकेज हो जाती है, ट्रांसफर नहीं होती, फाइल का फेलियर हो जाता है, तो कोई वही डजंट मैटर, वी आर हैविंग 3 कॉपीज। So Hadoop is having a feature of a thrice replication factor. 3 बार आपका डेटा का रेप्लिकास होगा, और अगर कुछ क्रैश हो जाता है, कोई इशू हो जाता है, तो हम वहां से इंफॉर्मेशन को कैप्चर कर सकते हैं। तो इट्स सिंपली मेंशन हियर वी आर हैविंग अगेन, अगर मेरी ये फाइल मुझे चाहिए ही चाहिए, मुझे कंप्लीट फाइल मेरी रिक्वायरमेंट है ही, और यहाँ से इंफॉर्मेशन मैं कैप्चर नहीं कर पा रही हूँ, तो फ्रॉम सम अदर एल्स द इंफॉर्मेशन इज स्टोर्ड, आई कैन कलेक्ट दैट इंफॉर्मेशन फ्रॉम दैट assigned location also. 128 plus 128 plus 124. So it's mentioned here, each data blocks are replicated thrice by default and are distributed across your data nodes. Clear beta? So it's mentioned here, as it is said, never put your all eggs in the same basket. So it means that हर सारे डेटा को एक ही ब्लॉक में मत डालिए, फोर्स मत करिए, उसको कहीं ना कहीं अलग अलग जगह पर रखिए। So this is the HDFS write mechanism, that is the pipeline setup. So we'll see how this write mechanism happen in the HDFS. So we are having a 2 blocks, that is the block A and block B. What is doing is that we are having a HDFS client, that is client JVM. ये हमारी client node है। Client के पास block A की information है, ठीक है। HDFS ने आगे forward करा information को, राइट रिक्वेस्ट ब्लॉक ए उसने दिया नेम नोड को कि मुझे ये जो मेरी इंफॉर्मेशन है ब्लॉक ए की, वो मुझे राइट करवानी है, आपके पास रखवानी है। नेम नोड ने क्या दिया? नेम नोड ने वहां पर प्रोवाइड करे डिफरेंट काइंड ऑफ एड्रेसेस, दैट इज DN1, DN4 एंड DN6 as per the requirement of the site. He had assigned certain locations where the information can be simply stored. So this information, the name node will get it back by the HDFS client. Now HDFS will move on that assigned location. So the HDFS, the client will move on from the core switch to the different switches, the space where it has been assigned to store that information. तो कोर स्विच के बाद से आपका डेटा नोड 1 के पास गया, उन्होंने पूछा आपके पास स्पेस है? यस, यहाँ पर स्पेस है। फिर वो आगे गया नेक्स्ट नोड के पास, उसने कहा आपके पास स्पेस है, आई कैन स्टोर दिस इन्फॉर्मेशन, उसने कहा यस आई एम रेडी, आई कैन स्टोर दिस इन्फॉर्मेशन। सिमिलरली नेक्स्ट नोड के पास गया, उन्होंने पूछा आप इनको करवा सकते हैं इन्फॉर्मेशन? यस, क्योंकि ये तीनों आईपी एड्रेसेस इज गिवन बाय द नेम नोड। नेम नोड को पता था कि ये जगह में स्पेस खाली है, यहाँ पर हम इजीली राइट कर सकते हैं इन्फॉर्मेशन को, इसीलिए उन्हीं एड्रेसेस को दिया गया। अगर मान लीजिए इन एड्रेसेस पे ऑलरेडी कुछ स्टोर होता है इन्फॉर्मेशन, या कुछ प्रोसेसिंग चल रही होती, तो ये एड्रेसेस आपके असाइन नहीं किए जाते ब्लॉक ए की इन्फॉर्मेशन को स्टोर करने के लिए। तो वही आपके एड्रेसेस आपके पास आए जहां पर हम इन्फॉर्मेशन को हम स्टोर कर सकते हैं, ठीक है बेटा। तो उसके बाद क्या हुआ, वो एड्रेसेस के पास वो गए, क्लाइंट गया, क्लाइंट ने पूछा yes you can store the information, yes they all are ready to store that information. तो उसके बाद क्या हुआ बेटा, राइट मैकेनिज्म में जब ब्लॉक को राइट करा गया, इंफॉर्मेशन आपकी राइट रिक्वेस्ट गई तो DN1, DN4 एंड DN6। इस कोड स्विच के बाद आपकी इंफॉर्मेशन गई, आपका ब्लॉक ए की इंफॉर्मेशन यहाँ पर भी आ गया, उसी का रेप्लिका क्रिएट करा, वो गया आपका नेक्स्ट ब्लॉक, यानी कि आपका डेटा नोड 4 के पास, क्योंकि हमें पता है कि हमें 3 आपका थ्राइस करना है हर एक ब्लॉक की इंफॉर्मेशन को। तो नोड 1, नोड 4 और नोड 6 आपकी 3 जगह आपकी इंफॉर्मेशन हमारे यहाँ पर स्टोर्ड हो गई, ठीक है। यहाँ पर मेंशन में हो गया ब्लॉक ए रेप्लिका 2 राइट रिक्वेस्ट, ब्लॉक ए रेप्लिका 1 राइट रिक्वेस्ट, ठीक है। इस तरीके से आपकी इंफॉर्मेशन आपकी यहाँ स्टोर्ड हो गई। इसके बाद इंफॉर्मेशन राइट करने के बाद यस वी आर मच इन रिक्वायरमेंट ऑफ द एक्नॉलेजमेंट। हमें कैसे पता लगेगा कि हमारी इन्फॉर्मेशन जो है वो प्रॉपर्ली राइट हो गई है कि नहीं हो गई है। डेफिनेटली वी विल रिसीव द एक्नॉलेजमेंट फ्रॉम एवरी डेटा नोड जहां पर भी इंफॉर्मेशन को हमने स्टोर किया है। Block A has copied the information, so acknowledgement will receive from the DN6. Similarly, the block A is copied and it will acknowledge the information of DN4 also. DN6 and DN4, that's which will move on to the information to the further next data node. यहाँ से भी block A ने copy कर लिया है और वहां से भी आपके पास acknowledgement आ जाएगा और ये तीनों का acknowledgement 4 switch से आगे जाएगा आपका क्लाइंट नोड के पास कि क्लाइंट नोड मैंने इन्फॉर्मेशन आपके लेके 3 जगह मैंने रेप्लिकास को स्टोर कर लिया है और क्लाइंट that is a JVM machine will simply inform to the name node that is a whole soul manager the master node that मेरा जो आपने जो ब्लॉक ए के लिए मुझे लोकेशन दी थी वहां पर हमने आराम से इंफॉर्मेशन को स्टोर कर दिया है। अब आप अपने डेटा को अपडेट कर लीजिए। अब इस एड्रेस पे कोई और इंफॉर्मेशन हम स्टोर नहीं कर सकते बिकॉज इट इज रिजर्व फॉर द रेस्ट ऑफ द डेटा नोड्स। ठीक है, so I hope you have cleared about that part. Further we will discuss in next class. Thank you.